Today we study X20 and Q. You can download the file from kpop.org, and if you visit there, you can click the table of contents, X series, X20, X20, Newton's laws of universal gravitation. N means, and Q means this one. You can click this to find a PDF file. And after recording this lecture, I will activate the link to this YouTube, and you can click this to subscribe the K-pop YouTube channel that can be found here. Okay, this NQ, the 20 NQ, explains some details about the two-body system. Especially, we review what the center of mass is. So it is a very simple one. What is the center of mass of two-body system consisting of M1 placed at x1 and M2 placed at x2? What is the center of mass? By definition, center of mass of a two-body system is the average value for the position vector. Weighted average. The weighting factor is the mass. Here, M1 over M1 plus M2 is the factor applies to the position vector for the mass M1. 2 divided by M1 plus M2 is the weighting factor multiplied to x2, that is the position vector of M2. We add them up to find out the center of mass. In general, if we have many particles, then mi, xi, sum of them, I runs from 1 to number of particles divided by the sum of the masses. This is the center of mass of n-body system. If you have a continuous mass distribution, it should be replaced with integral over mass distribution divided by the total mass. Everything is the same. What is the velocity of the center of mass? Velocity, if you have position, you take the first order time derivative of center of mass. We assume the masses are invariant if we study the Newtonian mechanics. Therefore, these coefficients are constant. If I take the derivative, then only the position vector takes the derivative. So, center of mass velocity of the center of mass is simply computed with this expression. Next, express the velocity of the center of mass in terms of the total linear momentum of the system. Okay, the linear momenta of the two particles are mass multiplied by the velocity. So P1 is the linear momentum of the first particle, and P2 is the linear momentum of the second particle. That is mass times velocity. Okay. The total linear momentum, capital P, is nothing but the sum of these two vectors. So, total linear momentum is the sum of two linear momenta, and by definition, mass times velocity added. By the way, we have this relation. What should I do? If I multiply both sides by the total mass m, that is the sum of m1 and m2, then this denominator disappears and is identical to the total linear momentum. Therefore, this capital M, the total mass, is multiplied to the velocity of the center of mass to find out the total linear momentum. In addition, if I return to the original form of the velocity of the center of mass, the velocity of the center of mass can be obtained by this, and because these are the linear momenta of the two particles, so center of mass velocity can be obtained by computing the total linear momentum first, and if we divide this one by the total mass, then we obtain the velocity of the center of mass. What is the acceleration of the center of mass? Acceleration of the center of mass, I can take another time derivative. That means we have mass times acceleration of the first particle, mass times acceleration of the second particle. So acceleration of the center of mass can be expressed like that. By the way, we can apply Newton's second law of motion. Then we find that mass times acceleration is the linear momentum's first order time derivative, and actually that is the net force applied to the particle 1. That is true for the second particle, so m2 x2 double dot is the time derivative of linear momentum of the second particle, and that is identical to the net force applied to the second particle. Then the acceleration of the center of mass is now expressed like this. What's that? This is time derivative of each particle's linear momentum. That is the net force applied to the first particle and net force applied to the second particle. So if I consider the fact that the superposition principle works for the addition of forces, the sum of net forces applied to particle 1 and 2 is the net force applied to the whole system, two-body system. What is the net F net of the system? Yes, their sum. Algebraic sum of the two vectors is nothing but the net force. By the way, the net force divided by total mass, according to our previous computation, net force on the system divided by the total mass is the acceleration of the center of mass. Therefore, if there is no net force at all for the system, then this center of mass does not accelerate and the velocity should be a constant of motion. If it is a zero because of the F net of the system, velocity of the center of mass is constant and the linear momentum, total linear momentum of the system is a constant. So that the derivative of this whole expression must vanish. If it is not the case, in most general case, just like what we derived, acceleration can always be expressed as a net force on the system divided by total mass, and net force applied to the system is the first order time derivative of the total linear momentum divided by the total mass. So this is the second law of motion applied to a system of particles, especially two-body system. And in fact, it is true for the n-body system. Number 6, what is the relationship between F1 net and F2 net if there is no external force? If there is no external force, the net force applied to the particle 1 is due to the interaction with particle 2. The net force applied to the particle 2 is the net the force applied by particle 1 because there is no external force available. According to Newton's third law of motion, that is the law of action and reaction, this force applied by particle 2 to particle 1 and the force applied by particle 1 to particle 2, they are the same in magnitude and direction are opposite. So their algebraic sum must be a zero vector. Because F net there is no external force, the only force is net force applied to particle 1 and particle 2 are the force applied by the other particle that is called internal force. The sum of the internal force always vanishes. So net force applied to the whole system because there is no external force. So sum of the internal force that is zero according to Newton's third law. So what is the consequence of the vanishing external forces applied to two-body system? Because the net force on the whole system is the same as the internal force sum that vanishes due to the Newton's third law, we arrive at the point that if F net equals 0, time derivative of the total linear momentum is 0, and that means acceleration of the center of mass is also 0. On the other hand, that is equivalent to the fact that the total linear momentum, that is the total mass multiplied by the velocity of the center of mass, is a constant vector. That's it. Thank you.